और आज मैं आपके लिए लेके आया हूँ स्टैटिस्टिकल मैकेनिक्स का कोर्स. So first of all, we will start with the introduction to the statistical mechanics. So what we are going to study in statistical mechanics is all about the systems which contains a large number of particles. So the number of particles will be around the Avogadro number 10 raised to power 23. So this many number of particles will be in a system, and we will be studying about them. So now, what does the statistical mechanics this word means? So statistical means the method of averages and probability. So we will be all doing is we will be taking averages, and we will be studying the probabilities of different configurations, and we will use these studies to understand the mechanics of this large number of particles. Okay, so now as we have already studied about the classical thermodynamics, see whatever be the subject, whether it is statistical mechanics or classical thermodynamics, the system has to be in equilibrium. Okay, so we are not talking about the dynamical system. So what this classical thermodynamic was doing was that it was making general statements and concerning the relationship between macroscopic parameters of the systems. So what are the macroscopic parameters of the parameters of the system? Just like the temperature. So what it was doing, it was making the statements concerning the relation of the microscopic parameter, just like temperature, based on the minimum number of postulates and without requiring any detailed assumption about the microscopic properties of the system. So actually, this classical thermodynamics is a bit older subject, older topic, and at that time, the knowledge of this microscopic properties of the system was not well known. So people was whatever they were doing, they were making some assumptions, and based on that, they were able to study the macroscopic properties of the system. Then there comes statistical mechanics. Again, for the system, the system has to be in equilibrium. And what it do is it is also making statements regarding the macroscopic properties, but based it on the microscopic properties of the particles in the system, and on the laws of mechanics governing their behavior. So basically, it yields all the results of thermodynamics. Whatever thermodynamics was telling, it is also giving the same results, but plus a large number of general relations for calculating macroscopic parameters of the system from knowing only its microscopic constituents. So basically, what it does, it just if you know like the in how many different possible ways you can arrange the system, and just by knowing that you can tell many macroscopic parameters of the system. We will see this in a minute. So let's move forward. So what are the microstates? You will heard this word quite often in statistical mechanics. So microstates refer to the specific detailed configurations that insist that a system can be in its microscopic level with while still having the same macroscopic properties. So what does this mean? So I'm taking an example of magnetic moments. So consider you have a three-spin system. Okay, so where you have three magnetic moments. So basically, what they can do, they can either point along the up direction or down direction. Okay, so what are there will be multiple different configurations in which they can arrange, but I will tell you one example particular where two of them are in the up direction and one is on the down direction. Now, this particular arrangement, this corresponds to some energy E naught. You must have been studied this equal to minus mu naught B. Okay, so whatever this magnetic moment corresponds to this two, that will come here. Now, I can arrange this particular state just like this. I will make the middle one down and the other two same. So basically this also corresponds to the same energy. What is this energy? This is the microscopic property. Microscopic property. Now what I am doing here, I am just changing the number of ways, number of arrangements. So basically this number of arrangement is what a microstate is. And what will be the macrostate then? The macrostate will correspond to these macroscopic properties of the system, just like temperature, the pressure could be same, the free energy or the entropy. Okay, so let's now we will also be discussing in this lecture series basically is about the statistical ensemble. So now what an ensemble means. Ensemble is the large number of mutually interacting, non-interacting systems. So first you need to focus on the word large number of. So basically again here the number will be about the Avogadro number 10 raised to power 23. And you have a large number of mutually non-interacting systems. So basically what you will have a multiple such systems. They will be identical yet not interacting. But they will have some common properties. These common conditions in which just like I will take the example of microchemical ensemble. So what we'll have there E, V and N. So basically this energy, total volume and total number of particles of all these things, all these mutually non-interacting system will remain same. While in the canonical system, in place of energy, we will be taking constant temperature. So all these things will have the same similar. They all will satisfy a similar condition. And in the grand canonical, you will have temperature, volume, as well as chemical potential. We'll study this in great detail. But as of now, let's try to go for a very important topic, which is known as the random walk problem. So this is a mathematical problem basically, but it is quite used in physical systems. So what is the problem? So the problem is you have a lamp here, and let's say you have a drunk man. He starts from this x equal to 0 where the lamp starts. So now you need to consider the drunk man such that he don't know whether he is moving his right leg first or his left leg first. So he's so much drunk. Okay. So what he do is the length of his every step is same. This is the L. The L is the step length. And so every time, let's say he is moving to right to this lamp post. So this probability that his right leg will move is, let's say, P. So what will be the probability that his leg moves left? So that will be 1 minus P, because the sum of the two probabilities should be 1, right? So I am saying that the probability with which he moves to right is P, and let's say the probability with which it moves to left is Q, and which will be equal to 1 minus P of cos. So now my question is, so let's say he moves total n steps. N is the total number of steps he moves. And now I want to know what is the probability that he will cover a distance, a total distance of m, total distance. And so basically that will be equal to, so this total distance which will be equal to m times L. So m is the some integer, let's say, because he will be moving like let's say x equal to 1, 2, 3, and towards left, let's say I can write -1, -2, -3, and so on. So this m has to be an integer which should lie, a maximum could be the total number of steps in the both directions. So plus minus n should be the range of n. So now we have a question. So let's say uh, m, this total distance, let's say he is taking 3 steps, n is equal to 3. And what should be the probability? What should be the probability that in 3 steps he is at the distance 3? So basically here. So what should be the probability? Or uh, he is here. Okay, that could be a problem. Or let's say his home is here. Okay, his home is here, and I want to know whether he is able to reach here or not in his in his house. Let's say this is at M. So this is the problem. Okay. So now how to approach this problem? So let's say this is your lab. Hmm? The same condition. Now what I am assuming is out of this total n steps, what he is doing is, let's say he is taking n2 steps towards the left and n1 steps towards the right. Hmm? So that what does this mean? The sum of these two, n1 plus n2, will become the total number of steps, right? Now, what will be the next step? Net displacement. So of course that will be the n1 minus n2. Okay. Now this n1 minus n2, it could be positive, it could be negative. What does positive means? That after these capital N steps, he is on the right side of the lamp. And what does this negative means? He is on the left side of the this lamp. So what you can say about this total displacement in terms of this what we say the total number of steps. So what I will do is just I will use these two equations to write the net displacement as 2n1 minus capital N. Can I do this? Yes, of course. So now let's say we will assume something. Okay. Here let's say n is equal to odd number. Okay. What does this mean? Odd. Odd means let's say 1. Okay. So since n is 1, so what does this mean? 1, 3, 5, let's say so on. So therefore this m will become 2n minus 1, meaning m is also odd. Yes, of course. And similar will be the case with the if n is even. If n is even, then this means m is also even. Okay. So you should note this point. So if the total number of steps, is even, then the final displacement, the net displacement has to be even. And similar case with the odd case. Okay. Now let's take an example where we have the total number of steps as 3. Okay. So now this net displacement has to lie between these two values, because this is 0. What he can do? What are the possibilities? This drunk man, what he can do? He will move all these 3 steps to the left, to the right side. Then what will be the displacement? This m value will be at maximum plus 3, and similar will be the case with on the other side here. So that will be the minus 3. Now I told you in the previous slide that this m value, whether it is even or odd, it will depend on whether n is odd or even. So now here n is equal to 3. So what does this mean? That n can take values only on the odd, like the odd value. What does this mean? 1, 3, and plus basically minus 1 and minus 3 also. Okay. So we'll show here also. So we will show this thing here also. So let's say this n1, which is the number of steps he is taking to the right, and n2 is the number of steps he is taking to the left. So let's say in the first condition he is not moving any step to the right. He's only moving towards the left all these three steps. So what will be the value of this m? So that will be minus 3, right? And what will be the configuration? First step, second step, and then this is the third step. That is the only possible way in which he can move. Uh, and now, let's say he's taking one step to the right and the remaining two steps to the left. So what does this mean? This m value has to be minus 1, right? And what will be the different type of configuration in which he can move? Two steps left, one step toward right. Now this one could be at any order, I can say. So this, basically this, not this. Okay, or this can be here and this. All these corresponds to the net displacement minus 1. Hmm? Now, these are all the possibilities with which he can move to a net displacement of minus 1, basically at this point. Now, let's suppose he is moving two steps toward right and one step toward left. So again, this net displacement will be 1, and the number of configurations will be like this. Again, there will be three possible ways in which he can move. Okay, and this, and one will be this, right? And now the last one is in which he moves all the steps toward right, therefore the net displacement has to be 3. And there is only one possible way in which he can do this. This is the only possible way, right? So these are the only possible ways in which he can move. And now where I have used this formula, uh, where I have used this thing, this net displacement n1 plus n2, sorry, this number of steps, total number of steps is equal to n1 plus n2, and the net displacement has to be the subtraction of these two. Okay. Now here, how many possible number of ways we have? We have total eight number of possible ways. So basically, if you see, this is the drunk man. Okay, so he has two choices. Either he go to left or he can go to right. So basically, how many choices he have? He has two choices. And how many steps he is taking? The total number of steps. He is taking 3. So basically, the number of possible ways, basically the number of possible sequences of steps in which he can reach to a point will be 2 raised to power 3, that is 8. Hmm? So you can do this for any kind of problem where you can take 2 raised to power n if you have two choices. Okay. Now, this will be a homework for you. You need to check the probabilities. Basically, if I say what will be the probability of all these states, all this configuration, choosing this particular net displacement. So out of three ways, okay, let's say since the probability of going to left was q, so the probability for this first step taking to left will be q, and this will be q, and this will be q, right? Now what will be here? It will be q, q, and p, or same for the others. So basically this will be q q, this will be q square p, and then here it will be p square q, and here it will be pq. So basically these are the probabilities with which all these can move. So now here I will also show you what does what does this macrostate and microstate means. So basically if you see here, for all these states, so all these states, basically all this one state, this particular configuration, you have a net probability of q cube, and this configuration is 1. So this particular state will be a microstate. And here in the second thing, where you have three particular microstate in this macrostate, and again three microstate in this macrostate. So basically you have four macrostates and 8 microstates within this. Okay, I hope you get the concept of microstate and macrostate also from this. Now you need to check whether this all the sum of these probabilities is 1 or not. Okay, so now the sum of these probabilities should be equal to 1. So how it should be? So if you see here, this is nothing but the expansion of q plus p raised to power q. And now, as you know that p plus q, basically the probability to take the right leg first or whether to left leg first, it should be equal to 1. So this has to be 1 cube or basically 1. So you can easily check this thing also. Okay, now what will be the probability? Now the probability of any one given sequence, basically you are taking n1 steps to the right and n2 steps to the left. It will be basically just the multiplying the respective probabilities. You will just as I have done in the previous step, I have multiplied these all these probabilities, just like if it is taking to the left q, and again if it is taking to the left then q, and then again q. So what I am doing is I am multiplying all these three probabilities. So here also, let's suppose he is taking total n1 steps to the right. So what does this mean? P into p into p, and I will keep on doing this multiply n1 times, right? And now also I have n2 steps to the left with probability q. So I will do q, 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 and keep on doing this n2 times, right? So what does this mean? This is equal to nothing but p1, p raised to power n1 and q raised to power n2. Okay. Now there are also the number of distinct probabilities. So basically, what are the distinct probabilities? Here, if you see, the probabilities were here. So, but there were some repetitions because of this internal arrangement, if I say. So these are not the distinct probabilities. So this all corresponds to the same probability. So the number of distinct probabilities will be the just like n factorial and divided by n1 factorial and then n2 factorial. This is the number of ways in which you can arrange. Let's suppose if you have n particles, out of which n1 are of one kind and n2 are of other kind. So the number of distinct possibilities will be like this. Okay. So now, in general, what will be the probability of taking n1 step to the right or basically n2 steps to the left in any order? So what will be that? So that will be nothing but n factorial divided by n1 factorial, n2 factorial, and this probability is p n raised to power 1, q n raised to power 2. Okay, I hope this is clear. So let's move on to the binomial distribution. So then the random walk problem is done. Now let's come to binomial distribution. So as you know this, what is this binomial expansion formula? So for any these two values p plus q raised to power n, you must be knowing this binomial expansion formula. So basically this is nothing but NCN and p raised to power n, q n minus n. This is all you know. So now also if you see in our previous probability function, so what was the probability function? If you see here, this is also if I put here n2 equal to capital N minus n1, so basically this will also become like a binomial expansion formula. Okay, uh, just like this. What I have to do, I have to just substitute m equal to basically the net displacement as n1 minus n2, and the total number of steps as n1 plus n2. So what does this mean? What I will do, from these two equations I will find out the number of steps to the left, number of steps to the right. Okay, and I will just substitute in this previous equation basically this w and n1, and I will get this probability function. So this is a very important formula. So by just knowing the total number of steps, and the net displacement, just by knowing these two things, you can find out the probability of finding the trunk man at a particular location. Okay, so we will be using this formula. So this is the important one. So let's discuss the case when the drunk man is taking a total number of steps as 3, and like he's so drunk that whether he is taking his left leg first or right leg first, the probability is equal, that is 2. Okay, so P and Q are equal. So what will be the number of steps? So basically he can move to what we say this right side. It could be 0, he can take 0 step, he can take 1 step, 2 step or 3 step. And in that case, what will be the net displacement? The net displacement has to be an odd number, as I told earlier. If this number is odd, then m has to be an odd number. So from -3 to 3, you can directly write. Now what will be the probability? So we will be using the previous formula. So this binomial expansion formula, or binomial distribution rather we say. So this is the formula. Here if you put P half, Q half, and nm, the values of n is equal to 3, and m values you can take all these different values, then you can find all these probabilities. So for taking the net displacement has to be, if it is -3, then what is the probability, and other two cases also. So now the interesting thing is, now let's say plot these values. So on the x-axis I am plotting n1. N1 is the number of steps taking to right, and I'm plotting the distribution of probabilities. So if the number of step is 0, then the probability is 1 by 8 here, and if it is 1, then it is 3 by 2, 3 by 8. For 2 also it is 3 by 8, and then 3 it is coming to be 1 by 8. Okay, so this is wn by n. So basically the probability of, out of these total n steps, I am taking n1 steps to the right. Okay, so I can also represent this in a different way. So here what I am doing, out of this out of this total n steps, I am reaching at some particular net displacement of m. So what will be the probability for that also? So the net displacement could be -3, 1, 1 or 3, and the probability distribution will look the same. So now if you see here, some sort of bell-shaped curve is appearing. So now what I will do, I will do this experiment with n equal to 20. Okay, then definitely I will find a bell-shaped curve. And let's say if I am taking n equal to 100 or even more, or let's say n is equal to 10 raised to power 23, then what will happen? So this will definitely come to a perfect bell-shaped curve. So this is what we this is what is known as the binomial distribution curve. Okay, I hope you got it. So now what is the physical significance of this thing? So the physical significance of this thing is that after n random steps, so basically this is also known as a random step. So because the drunk man don't know whether he's taking the step to the right or left. So the probability of the particle being at a distance n steps away from the origin is very small, as you can see here. The graph is like this, and here it is the origin. So Any steps away from this origin, the probability, this is the probability curve. So the probability is very small. Whether while the probability at finding this particle in the middle is very high. So this is what a binomial distribution is, and from this you can also understand why a drunk man can't reach his home so easily, right? Because the probability is very less. So we will be doing this. We will be using this concept of random distribution, or basically the binomial distribution, statistical mechanics. And okay, so let's end this topic here. We will meet next time. Thank you.